NASA is already training a team to take on the first crewed flight and the first human landing on Mars in history. Currently, volunteers are participating in a year-long mission to prepare astronauts to explore the Red Planet. They are living in an environment that imitates conditions on Mars, where they will fly in 2029. The voyage to the planet will take the astronauts 7 months. Notably, in the past, the longest space flights were the lunar expeditions, with the flight to Earth satellite lasting almost 79 hours, which is around 3 days. So far, NASA has only been planning expeditions within the solar system. However, in the future, the agency will send astronauts further away. One day, our technology will enable volunteers to reach the universe's edge. I see you're ready to become one of them. What deadly challenges will you encounter along the way? How far is the universe's edge, and most importantly, what's lying beyond? Let's assume you have infinite years to live, which you decided to spend on space exploration as a NASA volunteer astronaut. You arrive in Florida and go to the John F. Kennedy Space Center. The president shakes hands with you, and a vast crowd cheers, shouting out your name during the launch of the world's first crewed mission to the universe's edge. You receive an infinite fuel supply, and your voyage starts. To begin with, you need to go into outer space, but the problem is that the atmosphere doesn't actually end abruptly, it just becomes thinner and thinner. Scientists have defined its conventional boundary 100 kilometers above sea level, called the Kármán line. You'll reach it in just 4 minutes, but after that, your perception of space and direction will gradually change as gravity diminishes. The feeling is far from pleasant, as at this very moment, zero gravity is causing muscle atrophy, moving liquids around your body differently, and even changing your bloodstream. At the same time, you're lucky to know how to deal with this discomfort from the preparation course. Now, you can enjoy a stunningly beautiful view of your home planet from space. What could ruin such a wonderful moment? The pulsing noise in your ears and the crackling of the sensors. You notice that your radiation indicators on your dashboard are rapidly growing. Right now, at the altitude of 4,000 kilometers, you're entering the Van Allen radiation belt. It's an area around Earth that contains high concentrations of charged particles, such as electrons and protons. They form from cosmic radiation coming mainly from the Sun. You break through the danger zone as fast as you can, but there's no time to relax. After another 13,000 kilometers, a second belt, much bigger and more intense, is waiting for you, so you need to accelerate again. Your spacecraft will gradually go further from Earth, passing the orbits of Mars, Jupiter, and the other planets in the solar system. The next margin you are to cross would be the heliosphere, an area of near-solar space. It's quite a long way to go, 18 billion kilometers from Earth. It took Voyager 1 a total of 35 years to do it. The heliosphere is somewhat like a bubble of stellar gas surrounding every star, including our Sun. This bubble is constantly inflated by the solar wind, which extends far beyond Pluto. After the heliosphere, there are interstellar gas, dust, and fluxes of charged particles. The main danger here is that when the solar wind collides with them, it creates a blast, also known as the solar wind shock wave. If it wasn't for the heliosphere, the solar wind fluxes of charged particles from outer space would be bombarding Earth permanently, and life would have never appeared on our planet. But now, you need to go beyond this protective shell. It's crucial that the onboard cooling system doesn't fail, or you'll burn alive as the temperature in the border area can reach as high as 7,000 Kelvin. To compare, even on the Sun, it's lower by almost 1,300 Kelvin. By now, you've finally reached interstellar space. It's very dark here. You'll be flying in absolute darkness for nearly 300 years, and it's much worse than the dangerous challenges you've already been through because you'll spend all this time alone with your anxious thoughts. How many generations of your descendants have been born on Earth? Have people mutated over this period? Have the XX finally released their new album? Suddenly, a strange alien probe-like object unexpectedly emerges in your visual field, interrupting your thoughts. This spacecraft is Voyager 2, launched over 40 years ago. It's still exploring space, registering various objects like, for example, this ice comet that's coming right at you. The Oort cloud, an area of icy asteroids that surrounds our star system, extends beyond the reach of the Sun's magnetic field. It has trillions of space objects of various sizes, some of them only half as large as the Moon, and owing to this, they are classified as dwarf planets. But 1 kilometer across ice comets left over from the formation of the solar system make up the majority here. That's just what you need to chill after the heliosphere's flaming edge, but there's a new danger for your ship. Powerful energy fluxes and magnetic fields raging in the heliosphere could disable the electronics, and after you enter the Oort cloud, you'll have to maneuver among the comets manually. But if your spacecraft tackles this, you can behold the full picture of the Milky Way. Even though its center is almost 26,000 light-years away from Earth, here you can observe 400 billion stunningly beautiful stars. However, the Milky Way is quite full of gamma-ray bursts, dust clouds, and, most terribly, black holes. There are about 1 billion here. The most massive of them is in the galaxy's center, called Sagittarius A star. Its mass is estimated to be about 4 million solar masses, which is almost as large as our entire solar system. If you accidentally wander off course and fly past it without even touching its gravitational field, it'll be enough to expose your module to high temperatures and gamma-ray radiation. But luckily, the nanobots have finally fixed your navigator, damaged by the comets from the Oort cloud, and you can adjust your path to avoid the black hole's gravitational field. Now, it won't drag you into the terrifying unknown, turning your spaceship and body into spaghetti. Although some scientists think the black hole could serve as a teleport to the universe's edge, you'd better still stick to the assigned path unless you want to fail the mission. Besides, you'd have a chance to express yourself in a stressful situation, as once you cross the Milky Way's edge, there would be even more problems on the way to the universe's edge. Your trajectory will take you through hundreds of other galaxies. The first one to cross will be our closest neighbor, Andromeda. If you approached it at light speed, you'd only think it took you 1 year, but your family and friends here on Earth would have to wait over 2.5 million years until you reach Andromeda, and as much again until the radio signal comes back to Earth to inform them of your arrival. To put it simply, you'd experience the famous interstellar scene where Matthew McConaughey cries over the years he's lost. But in fact, the challenges you're about to go through are not always related to threats overboard. Sometimes, the danger would be lurking inside you. The thing is, by the time you've reached Andromeda, Earth, this pale blue dot, will have dissolved in the picture of space. You can be the first human in history to experience the agonizing lost in space effect. Psychologists doubt all astronauts can accept the fact that they can't see their home planet. The consequences may vary from ordinary depression and homesickness to full-scale psychosis and even suicide. However, your flight might turn so intense that you just won't have time to see Earth disappear, since right at this moment, your ship is experiencing turbulence due to passing close by a globular cluster. Scientists believe these are remnants of star systems that Andromeda tore to pieces and absorbed in the past. Yes, you're in the territory of a space cannibal. Approaching the globular cluster can seriously influence your ship's trajectory, so seriously that one of the stars can pull you dangerously close to itself. There are about 13,000 such clusters in Andromeda. Having passed them, you leave the local group of galaxies and enter the Laniakea supercluster. You look out of the porthole and giggle silently. You see, Laniakea is a Hawaiian word meaning immense heaven. It's noted that no one believed someone would ever reach this destination, but the journey doesn't get easier from there. Passing it is much more dangerous than crossing the Milky Way or Andromeda, being approximately 100,000 times more perilous. Speaking more precisely, this is due to the number of galaxies in the supercluster Lanai, which spans 520 million light-years across. The most dangerous area here is the active galactic nucleus. Unlike ordinary supermassive black holes, these nuclei are powerful sources of electromagnetic radiation in the universe. Inside them, there's also a black hole actively absorbing everything around it, forming an accretion disk that releases enormous amounts of energy. These X-ray and gamma bursts are far more dangerous than anything mentioned before. They are so intense they can harm neighboring galaxies, let alone a tiny spaceship. Even if you manage to avoid their influence, you'll still be very far from your destination. This brings up a critical question: how much longer will it take to fly to the edge of the universe? You've been traveling for a long time, yet there's still no sign of it. Is the edge real or not? This uncertainty presents another challenge for your psyche, making you wonder if your voyage has a destination at all. It might turn out that the universe has no edge, a topic still debated among scientists. The observable universe, as seen thanks to modern technology, isn't deemed very large, even though it spans 93 billion light-years. So why do scientists think there might be something beyond it? Their theory suggests that after the Big Bang, the universe began expanding, and the process hasn't stopped. Observable data indicate that the universe looks homogeneous at large scales, meaning its qualities and the distribution of matter and energy don't change relative to direction and location in space. This homogeneity suggests that the universe could even be infinite. Moreover, it'll take quite some time before our technologies, no matter how advanced and powerful, can cover the complete picture of the universe, though it might be impossible to cover it all. However, the absence of observable boundaries isn't a problem for most scientists who rely on existing knowledge of space and physics to state that the universe does have an edge. This is because infinity would imply that the universe is boundless not only in space but also in time. In such a case, space would contain infinite stars, making the sky blindingly bright on Earth around the clock. However, the darkness of the sky proves that space hasn't existed forever. Furthermore, scientists believe that if the universe were unlimited in size, we would find incredibly long cosmic waves from massive black holes. Jean-Pierre Luminet from the Paris Observatory in France notes that NASA's WMAP spacecraft, which produces relic radiation, has never detected abnormally long waves, suggesting that space is not infinite. However, the role of cosmic waves in this controversial matter is not yet over. Glenn Starkman, a Canadian physicist and professor at Case Western Reserve University, believes he has found a way to use them to define the universe's boundaries, even though they're beyond our visibility range. Starkman claims that cosmic audio waves, which spread in the universe when it was still young, can help us understand its shape. This could eventually reveal where to look for its edge, if it exists. If the universe has no shape, it means it's flat and thus infinite. However, if it has some curvature, the universe is closed. Reflecting on history, just a few centuries ago, people believed the world was flat because they could only see the horizon and had no way of observing the planet's curvature. New technology helped us see Earth from afar and prove its roundness, which might also apply to the universe. But even after traveling such a long distance from Earth, you still can't see the edge or curvature of the universe. You're likely too small to observe it from the outside, and Starkman's planned research, which could shed light on the matter, will take considerable time. Nevertheless, some researchers are already proposing hypotheses. Jan Levin, a theorist from Cambridge University, envisions the universe as a donut, explaining why its curvature hasn't been observed from your space module. You, our planet, and the part of the universe you've passed through are inside this donut, unable to break through it. We can't access a dimension that would allow us to view our three-dimensional universe from the outside. However, if the universe is donut-shaped, wherever you direct your spaceship, it would eventually return to its starting point. Yet, all these hypotheses about the universe's shape emerged before Oliver Philcox, a junior fellow at Columbia University, used a supercomputer to create a map of distances between millions of galaxies. This map suggests that the universe can be neither an infinite plane, a sphere, nor a donut because it's asymmetric. This indicates that some force, perhaps in the earliest moments of the universe's existence, caused it to expand unevenly. This represents an entirely new, unknown type of physics. Such fundamental shifts imply that the universe's edge in another direction could be much closer than the one you've been heading toward for so long. Realizing this, you continue your voyage, feeling increasingly moody. Gradually, it becomes unbearably cold on board, and suddenly, your spacecraft hits a kind of transparent wall. However, it's not a solid wall but a jelly-like barrier, making you feel like a fly trying to escape from sticky jelly. Awfully cold, you suddenly break through the universe's edge. So, what lies beyond the edge? There are many hypotheses. The first suggests that you'll face an absolute void, the greatest nothingness. This hypothesis implies that beyond our universe, there is no matter, space, or time, a concept difficult to imagine. but the reality might be the opposite. Our universe could be part of the so-called multiverse. In this scenario, hundreds of billions of light-years away from us, there might be other universes, each with its own physical properties, content, and evolution principles. This means there could be life that didn't form from water but from something else entirely. However, this raises the question of why we've never seen those other universes. The most probable answer is that these worlds are so far away that by the time their light reaches Earth, it has lost so much energy that we physically can't see it. This is what the hypothesis of parallel universes suggests. It also states that there are many universes, and they resemble giant bubbles, each containing a copy of our universe, but subtly different. Each bubble includes the same galaxies, stars, and an exact replica of planet Earth with the same inhabitants, but every universe has its peculiarities. Possibly in one universe, people walk backward, while another has been destroyed by an alien civilization. Fortunately, since we can't reach beyond our universe's edge, representatives from other worlds can't enter ours, unless the universe's edge is much closer than we suspected. Stephen Hawking also supported the parallel universe hypothesis, believing that space bears their imprints. These are spots where bubbles containing other worlds touch one another. Now, take a look at this map of relic radiation in the universe. Based on our current understanding, the radiation temperature should be approximately equal throughout the cosmos, as the universe is homogeneous. However, scientists can't fully comprehend how the CMB cold spot formed. In this area, the microwave radiation temperature is 70 microkelvin lower than the surrounding space, where it's 2.7 Kelvin. Strangely, there are almost no stars or galaxies in this area. Yet, astronomers working with data from the Voyager spacecraft claim that our space probes are constantly receiving strange signals from this spot. Even today, no one can decipher them or explain how the signals emanate from this dead zone. If this spot is indeed the imprint of a parallel universe, it suggests that the universe's edge is there, only 2 billion light-years away from Earth. As a result, NASA could potentially send people there much sooner than reaching the actual universe's edge. Would you volunteer for such a mission? Write in the comments.